So friends, welcome once again to my channel Puzzles Pandit, and today we are going to solve this puzzle named Stampede, and that is by James Sinclair. And this puzzle on German Master has a 3 star of difficulty, that is medium difficulty, but the rating is I think something like 96 or 97%. I think, but definitely more than 95%. I don't remember the exact number. So let's read the rules. So normal Sudoku rules apply. That is each row, each column, and each 3 by 3 box must have the numbers 1 to 9 only on without any repetitions. Digits on arrow sum to the number in the connected circle. So right. So these circles we are saying, right. So we should be placing digits on this arrow such that digits on this circle such that it will be the sum of the digits on this arrow. So for example, if we have something like 1, 2, um, 1, 3, and 4, then this must be 8 because the sum of 1, 3, and 4 is 8. So that's how we need to place the digits here. Along green lines, digits must differ from their neighbors by at least 5, right? So this is called as German whisper lines, and we should be placing digits on the German whisper line such that the neighboring two digits must have difference of at least 5. That means if we have 2 here, this should be either 7, 8, or 9 because all other digits are not far away from 3. So that's how the German whisper line works. Purple lines contain a set of non-repeating consecutive digits in any order. So these are called purple lines are called as the rain band lines, and we should be placing digits such that they are consecutive and but not necessarily in order. So it's not necessary that you should have 4, 5, and 6 here, but 4, 5, and 6 must be possible. Must be there. 7 is not possible because this is not having 5, and there is a gap there. So this should be continuous. So this is possible. So you can have 6 here and you can have 5 here. So something like this is possible. This in any order. Digits in cells with a shaded square must be even, right? So these two shaded square I can see. Those digits must be even, and digits in cell with a shaded square must be odd, and this must be an odd digit. So right. So those are the rules. So with those rules, let's start this process. So the first thing I am seeing is that this German whisper line, and one of the trick or secret of the German whisper line is that German whisper line will never contain the digit 5 on it, because think about it, if you have 5 here, what are you going to place on the neighboring digits? It should be either 0 or 10, and both are not valid Sudoku digits. So 5 can never come on German whisper line. And the second is that um, between the two groups, right? If you divide the numbers into group 1, 2, 3, 4, and 6, 7, 8, 9, right? Let's call this as lower group, and this called as upper group. Then the digits must alternate between lower group and upper group. So, for example, if there is a digit from one of the lower group from here, I mean one of the digits from the lower group, then these both digits must be from 6, 7, 8, 9 because this cannot be 1, 2, 3, 4 because those digits are not far away from here. So only 5 away digit uh, possible if this is lower digit is 6, 7, 8, 9, and then again if this is 6, 7, 8, 9, right? For example, let's say this is 6, 7, 8, 9, then this must be again from the lower group. So the lower group and upper group digits they take alternative positions, and that means we can do a little bit of coloring. So let's say this is one coloring, we don't know which whether this is lower or upper, but that means this will be different group, and then this will be same group. So we know that, see, both these digits are from the same group, both these digits are from the same group, and these 3 digits are again from the same group. So at least that much of information we have got. Right. And now, yeah, it will help somewhere here on this rainbow line, because now we know that there must be a 5 on this rainbow line. And the reason is that, see, we know that both lower and upper digits are here. So either one upper digit and one lower digit are present here, because these are from the different groups. So if this is 1, 2, 3, 4, this must be from 6, 7, 8, 9, or vice versa. If this is from 6, 7, 8, 9, this is from 1, 2, 3, 4. But we know that one digit from both of group must be present here. Now imagine this is not 5. So that is one of the thing of German whisper. If it do not contain 5, that means it will either contain all the digits from the upper side or lower side. That means this will be all either 1, 2, 3, 4 or 6, 7, 8, 9. So imagine this is all 1, 2, 3, 4. Now you cannot have any lower digits to be placed here, right? And similarly, if these are all 6, 7, 8, 9, right? Again, you do not have any digit to be placed from the higher group here. That means we know that the digit 5 must be present here. And if you see, right, digit 5, right? So 5, 4, 3, 2, or 5, 6, 7, 8. That means 1 and 9 is not present here. That is another what we can corollary for this. And now let's come here. Right. So, right. So, of course, what is happening is that we know that this is 6 and 8, 9, because if you even put the minimum digits here, which is 1, 2, 3, that sum to 6. That means whatever digits you are going to put here, the sum here will definitely be more than 6, 7, 8, 9. But what we need to do is that, right, we need to look at all these digits from a single list. That is, look, all these digits, right, they belongs to the same 3 by 3 box, right? That means they all should be different, and the minimum they could be is 1, 2, 3, 4, 5, isn't it? Right? The minimum they could be 1, 2, 3, 4, 5. None of these three could repeat. That means it's not possible that one is here also and one is here also. So they all from different, and this could be minimum 1, isn't it? This could be, sorry, let's put this thing. What I'm doing, let's put this. Yeah, this could be minimum 1, and this is minimum 1, 2, 3, 4, 5. Right. So if you look together at all these digits, right, the minimum here is 1, 2, 3, 4, 5 and 1. And 1, 2, 3, 4, 5, if you add them together, you get 15. And then if you add 1 into it, 16. So minimum sum of all these is 16, right? And that means the minimum sum of these two are 16. Minimum sum of these two are 16. That means 6 is not possible here, because if you have 6 here, you need to put 10 here, because minimum sum is 16. And that means this is, they both are 7, 8, 9. There is no 6 here. And it cannot be 18, right? This sum cannot be 18, because then you have to put 9 and 9 here, which is not possible because they both are in the same row. So this is either 16 or 17. There is no other option, and 9 is there. So 16, because it is minimum, and it cannot be 18, because then that will put 9 in here. So this is either 16 or 17, but any case 9 is there, because if the sum is 16, it will be 7, 9, and if it is 17, it will be 8, 9. So in both cases 9 is there. Yeah, right. And now this thing, so now this digit, right, if this is 15, right, we know that this is 16 or 17. Minimum this is 15, so this must be 1 or 2, right? This digit could be only 1 or 2. It cannot be more than 2, because if it is 3, the minimum sum of this will be 15 plus 3, 18, and then both this will be 9, and which is not possible, which we have already discussed. So this is only 1 or 2. Okay. Now we have to think that where this digit goes here in this box, and where this digit goes in this box. So this digit cannot be on its arrow, because obviously if it is on its arrow, then both the other digits must be 0. That's not possible. It cannot be here by Sudoku. So this digit must be somewhere here, right? So let this be red. So red is somewhere here. Can it be here? So obviously if it is 8, it cannot be here, because 8 means these both must be either 1, 1. So that is not possible. If it is 9, then of course again it is not possible, because you cannot place 9 on any of the arrow. 7, can this be 7, and then these both will be 1, 1? No. 7 is also not possible. Okay. 7 is not possible, because if this is 7, the only possible sum of 7 is 1 to 4. So if this is 7, all these must be 1 to 4, and then you cannot put 1 here. So if this is 7, minimum this will be 2, so sum will be 9, and minimum this will be 1, so that will become 10. So yeah, so even if it is 7, it is not possible to be here. So that means this digit is not present here. So this digit is either present here or here. And I think similarly we can say that this digit is also present either here or here, which is yellow, is either here or here. With the same logic that it cannot be here it cannot be on its own arrow, right? This Sudoku, and it cannot be here, because even if it is 7, this is possible, right? I mean, this is clearly easy to see that if this is even 7, the other digits minimum will be 1, 2, and that sums to 7 plus 3, 7, 1, 2, which is 10, and that is not possible. So clearly this digit must be here and here. So that means we can say that Oh, so those these two digits are here. So these both are 7, 8, 9, and again 9 is one of here. We don't know whether this digit is here or this digit is here, but we know that these digits repeat here, and that means 9 is here. And now this coloring comes into picture. That means, see, this is one of the higher digits, and we know that both these belong to the same group. That means this is also from the higher digit. This is 6, 7, 8, 9. Oh, and now we know the coloring group. That means this is higher group. So that is 6, 7, 8, 9. And this is lower group, which is 1, 2, 3, 4. This cannot be 6, right? Because if this is 6, the only digit far away from 6 is 1. And that means both this has to be 1. So this cannot be 6. Similarly, can this be 4? Yeah, this can be 4 because then both could be, these could be 9, but these are not seeing each other. So that's why. But this definitely is not 6. So now, see, now what is happening is here. Now what is happening is on this arrow. Okay. See, we know that 3 lower digits have gone here. And in a single row, column, or 3 by 3 box, you can only have 4 lower digits, 4 higher digits, and 1 5. Right? I mean, those are all the Sudoku digits that are available here. But 3 lower digits are gone here. Right? 1 2, 1 2, 3 4, 1 2, 3 4. So maximum there will be 1 lower digit here and 5 here. Isn't it? And that means minimum this will be 6, 7, 8, 9. Because if this is 5, this will be either 1, 2, and 2, 3, which is not possible because even if these both are low, then you have 5 low digits here, which is not possible. So 5 is here, 5 or higher number is present here, and that means this is 6, 7, 8, 9. Oh, and not only that, one of the lower digit is present here, isn't it? Oh, okay, right. Because even if you see only one lower digit is present here, right? So even if you take that as the highest 4, so okay, okay, oh maybe, okay, right. Sorry. The other way. Let's take it the other way. That there is no lower digit here. So the only possible digit is 5 and 6. The lowest digit, if they are not one of the 1, 2, 3, 4 is 5 and 6, and that sum to 11. 5 and 6. That means one of the lower digit is here, and that means all these are higher digits, isn't it? All these are higher digits or 5 or higher digits. All these are 5 or higher digits. Oh, that means both these are higher digits because 5 is already here. Oh, higher digits is our green, right? Maybe my bad. Let's change the color. So both these are higher digits. We don't know this. Let's cancel because this could be 5 also. We don't know that, but definitely these both are higher digits because 5 is here, so this cannot be 5. So both these are higher digits, and now we have 3 higher digits here. Suddenly, and that means, yeah, that means now this can have maximum 1 higher digit, isn't it? Right? Because if this has 2 higher digits, again we will have 5 higher digits here, which is not possible. That is, this is having maximum 1 higher digits. So this is either this is 4 long, right? So that means it can maximum go up to 6. So 6, 5, 4, 3, or 2, 3, 4, 5. Right. So this can, if it is on maximum on the higher side, it will be only 6, 5, 3, 4. Or if it is on the lower side, then it will be 2, 3, 4, 5. Because 5 must be there. And that means both 3 and 4 digits are there. So either this is 2, 3, 4, 5 or 3, 4, 5, 6. It cannot be anything else. Okay. And now look, 3 and 4 are here. That means this is not 3 and 4. Oh, 1, 2, 1, 2. 1, 2, 1, 2. So this is pair of 1, 2, 1, 2. That means 1, 2 cannot occur here. This is 3, 4. Right. And now look at this. Look at this. See, we have already established, right? One of the lower digit must be here because imagine if lower digit is not there, the minimum this is 5, 6, which is 11, which is not possible. But both 1 and 2 are gone here. That means the lower digit that is only available here are 3 and 4, and that could be with 5 and 6, and But whatever it is, this could be only 8 or 9, because for 7 it could be 3 or and only one digit will be here. That means 5 must be there, and the other smallest digit is 3. So this is minimum 8 or 9. This cannot be anything else, because minimum this is now 3 or 5, right? Because they both cannot be 3 4, right? Because then you cannot have anything here. Only one of the lower digit will be here. So even assuming that the lowest 3 and the other is 5, this will be 8. So this is minimum 8. 6 and 7 is not here, so that's 8. Oh, this 3 4, right? So now there is no 7 here, and there is no 7 here. Oh, 8 9 8 9 pair we got suddenly. Okay, right. So now this is x wing of 9, isn't it? Because 9 is here and this is 8 9 pair, and by x wing means, see, we know that in this column 9 is only present at these two positions, and this column also 9 is only present at this position. That means this forms an x wing, and that means there is no 9 in this column, so this cannot be 9. And now where is 9 in this column? Can this be 9 9 7 8? Oh, this is only even digit, right? So that's 2 4 6 8. Oh, we know that this is only higher, right? So this is 5 6 7 8 9, isn't it? 5 6 7 8 9. We know that this cannot be low. This is 2 4 6. If this is 2, that's 2. That will be 2 3 4. So but this cannot be 4, right? So this cannot be 2, because if this is 4, I mean this cannot be 2, because then maximum this will be 2 3 4. This must be 3 or 4, which is not possible. So this cannot be 2. Oh, this cannot be 8. This is 8 9 8 9 pair, so this cannot be 8. And now this cannot be 9, right? Because if this is 9, this must be 9 8 7. And where are you going to put 8 here? This cannot be 8. And that means this is not 9. Can this be 8? 8 means this is 8 7 6 8 7 6. That's fine. This is 7 6 8 5. Okay. Yeah, but now where is 9 in this column? Where is 9 in this column? It is not here, because this is on arrow. It is not here because this is x wing of 9. It cannot be here. It cannot be here because it is on the rain band, and 9 8 7 is not possible on this rain band. It's not here. It's not here. It's not here because it is again x wing of 9. It is not here because this is lower digit. The only 9 possibility is here. Okay, I'll remove the pencil mark. Check pencil mark. And that means this is 8. That means this is 9. That's not 8. That's not 9. We know that one of these must be 9. That means that's 9. This 8 will give this as 3, right? Because 4 cannot be, 4 is not far away from it. So that's 3. That's not 8. That's 3 means now this is 4 5, right? Because 4, this will be minimum 4, and it can only go with 5 to give 9. So that's not 5. 6 7 6 7 8. This is 6 7 8 by Sudoku. 6 7 1 2 8. So we don't know this, right? This could be still either 1 2 2 3 4 5 6 or 4 5 6 7. So can this be 8? 6? That's 6, that's 5 and 4. Okay, that's fine. What is this now? This cannot be 8. 1, 3, 5, 7, isn't it? 7, 8, 9. Oh, yeah, right. We know that this is either 16 or 17. So if this is 7, this is 16. And if this is 8, this is 17. Okay. And because we don't know, oh, this is not 9. We know that, by Sudoku, we can simply say the torque by from here. 6, 7, 8, 1, 2, 3, 1, 2, 1, 2. What's this now? It's 1, 2, 6, 7, isn't it? That's low digit. 8, 9, 6, 7. Oh, 9 is one of this. Oh, that's not 9. Let's remove the pencil mark. Let's not get the there. And 9 is one of here, isn't it, by Sudoku? 9 is one of these. But look, 9 is one of these, and that means if 9 is one of these, the only arrangement possible is 7, 8, 9. And that means that digit is here. See, this is 7, 8, 9. That means this is only 7, 8, because 9 is one of these. These are 7, 8, 9 with 9 here. But the important thing is this digit is here. So this is red. And now red is somewhere here. Can it be here? Making this 7, 8 pair, or I don't know. Oh, now suddenly this is 1, 6, isn't it? Because this is green whisper line. It should have one of the lower digit and one of the upper digit. And which upper digit is remaining because of 7, 8, 9. So this 7, 8, 9 triplet is gone. The only upper digit remaining is 6. And that can only go with 1 because the only digit 5 away from 6 is 1. So this is 1, 6 pair. So from nowhere we got this 1, 6 pair. Anything else can we do that? So this is 7, 8, 9, 9, 9, 9 is here, 9, 9 we have done, 8. This is 7, 8. So, oh, we know that. Right. So this is, oh, sorry, this is not actual digit. So this digit is somewhere here, isn't it? Because it is here. And that means digit is somewhere here. So red is somewhere here. Right. I think this is very limited. Okay. Right. See, we have already established, right, that this sum must be 16 or 17. Now imagine this is not 1. If this is not 1, that means this digit is 2, 3, 4, 5, 6. That itself is 20, which is not possible. That means 1 is somewhere here. Am I correct? Because the number, triangular number, that is if you do 1 plus 2 plus 3 up to 6 is 21 and minus 120. So if 1 is not here somewhere, the sum of all these 20, which is not possible because this will not come here, and that means this is not 1 because 1 is somewhere here. 1 has to be here somewhere. So can we put that? Let's put that like that way. So 1 is somewhere here. Can it be 3? Because if it's 3, again we have 1, 2, 4, 5, 6, which is 18. Right? If 3 is here, that means 3 is absent from here. The minimum this is 1, 2, 4, 5, 6, which is triangular number of 6, 21 minus 3, 18. Again, that is not possible because they both will be 9, 9. In fact, if you add 1 here, then that will be even more impossible because it will become 19. That means 3 is also somewhere here. So that's not 3 also, and that is only 5 or 7. So this is only 5 or 7. Okay. Hmm. Anything more we can do here? Can this be? So if this is 5, 5 is not present here. That means it will be 1, 2, 3, 4, 6, which is 17. 17 plus 1, 18. Oh, okay. Wait. Maybe it should be like, if this is 7, the sum will be 16. This will be 5, right? If this is 7, this will be 5. The sum is 16, and 16 is minimum, isn't it? Which is 1, 2, 3, 4, 5, and 1 here. But 5 is here, so that is not possible. So this is not 7. This is 8. Let me do it one more time. If this is 7, the sum is 16, and this will be 5. But then this is not possible 16, right? Because this must contain 5. Because 16 means this is minimum 1, 2, 3, 4, 5, and this is 1. That will only give you 16 here. But that means this should not be 5, but this will be 5, this is 7. Right, so that means this is 8. And there is no 7 here, that's 8, 9, 8, 9 pair. That's not 8. Let's remove this pencil mark 9 also. That's 8, 9, 8, 9 pair. That's 6, 7. 8, 9, 8, 9, 1, 6. That's 5, 7. Can we get these digits now? Now 8, yeah, 8 must have 1 here, right? So there is no 1 here, because 8 is either 1, 3, okay, I have to write this out. 8 is either 1, 2, 5 or 1, 3, 4, isn't it? So if this is 1, 2, 5, if it is 1, 2, 5, 1, 2, 5, this will be 3, 4, and this will be 2. But if it is 1, 3, 4, 1, 3, 4, this will be 2, 5, and this will be 2. Because that's 9, that's 1, 2. No, I'm not sure now. Oh, wait. Okay. Maybe, where is 8 here in this box? Right? So by Sudoku, now it is not here, it is not here, it is not here, it is somewhere here. And now this rainman cannot have 9. That means this is 6, 7, 8 rainman. 6, 7, 8 rainman. And 8 is somewhere here, right? That means that is not 8. 8 is somewhere here. That means that is not 8. That's 6, 7. So this 6, 7 must be same as this 6, 7. Can we say that? Yes. 8. And this is, look, this is now 6, 7, 8, 9 triplet. This is not 8. Oh, that's 6, 7, 6, 7. So that is it. Wow. That 8 means now this must be 6, this must be 7. That's the only possibility of rainband here. And now look, 8 is on this rainband, and it cannot go with 9. That means that's 7, 8. And that 7 means that's 6. That's 7. That's not 7. And that's 7, 8. This is still not getting clear, isn't it? This could still be both 6, 7, yeah, right. 2, 3, 4, 5, 6 or 2, 3, 4, 5. But what are these 3 digits now? This must be limited, right? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3. Oh, this is not 1, because we see both 1 are here. That's not 1. This is still somewhere now. 1 2 1 2 6 7. We know that this is 7 8 5 5 3 5 2 could be this one 6 7. This could be anything, right? Still 1 2. Any more help from 8? Oh, none of this is 8 or 9. 7 8 8 9 8 9 3. Can 3? Yeah, 3 can go for 8 or 9 both, right? Oh, this 8 is giving this 9. Wow, so easy. Why didn't I see that? And that's 8. So that means this is yellow and this is red. Right. How does that affect this 9? So that's not 9 now. That which we know. 9 is not here. 9 is not. 9 is one of these two. And that means that's not 9. That's 9. See, 9 in this box, it cannot be here by Sudoku. It cannot be on the arrows. It's not an even number. It must be here and it cannot be present on the arrows. Because if you put 9 on arrows, the other number should be 0 for this to be a single digit number. And that means the only possibility for 9 is here. And we are now remaining with how many numbers? 1, 2, 3, 4, 5. Okay. Oh, 3, right? So 3 cannot be here. Is 3 giving us something? This is even digit, right? So it is 2, 4 or 8. In fact, it has to be 8, right? Yeah, this has to be 8 because see 8 is somewhere here, but it cannot be on the arrows because if it is on the arrows, this must be 9 and they both cannot be possibly 9. That is 8 is here. 6, 7, 8, 6, 7, 8, 6, 7. 1, 2, 1, 6, 1, 6, 7, 8, 7, 8, 9. Oh, 7, 8, 7, 8, 9, 7, 8. And 6. All the upper digits are gone here. This is lower digit, isn't it? What is our lower digit? Pink. This is lower digit, right? Because in this, we have 7, 8, 7. In fact, 7, 8, 7, 8. This is 9. That should be the clear. That's not 9. 7, 8, 7. Oh, this is 7 now. That's 7 and 9. So that's not 7. That's 7. That's not 7. That's 6, 8, 6, 8 pair. Let's remove this unnecessary. That's 7. That's 7. This still could be 1 or 2. Okay. 7, 7, 7, 7. 7 is one of these, isn't it? But can 7 cannot be here, right? We have established that, right? If 7 is here, these both must be same now, 1, 1, which is not possible. That means this is 7. That cannot be 7. 3 is, we have 3 at 3 places. Okay, let's continue this. So this is 7, 7, 7, 7, 7. Oh, 7, 8 is here. Oh, so that gives 8. That gives 7 because of this. This is low, right? 1, 2, 3, 4. But we have 1, 2 here. So that means this must be 2, 3, 4. This is high, right? High is what our thing. High means, but it cannot be 7. It cannot be 8. It could be 6 or 9. But it cannot be 6, right? Because 6 will need 1 on both sides, which is not possible. So that means this is 9. That's again low number. Oh, this 9 gives this 9. Okay. Let's do that first. and that 9 gives this 9, and we have done with 9. Okay, right, we have done with 9. Now that 9 gives this as a lower digit. We don't know what it is. 1, 2, 3, 4. Cannot be 4 because then again you will have 9 and, but this is now high digit, and the only possibility is 6 because all other high digits are looking at this 7, 8, 9. That's 6, and that means that's it. That is 1 because that's the only 5 digit away from here. That's not 1. That's 2, 3. Oh, where is 1? Only here because this 2, 3, 2, 3 pair. 1, 1, 1, 6. That's 1. And is 1 helping here somewhere? No. Now 1 is here or here. 2, 3, 1, 2, 6. Okay. 3, 4, 5. 6 is, oh, 6 is somewhere here. Okay. But we don't know. This, can this be 6? Because then that will remove 6 from here and we'll get something else. 6, they give 1, 5, right? Or 2, 4. Okay. So we have done with 9. What about 8? Is Sudoku helping us here? 8, 8. 8 could be here or here, isn't it? Okay. Oh, 7 here, right? 7 looking at this, that's 8. I have done Sudoku earlier. 2, 3, 4, 5, 1, 6, 2, 3, 4. Now 8. 8, 8, 8, 8, 8. 8 is one of these. 8, 8, 8, 8 is one of these. Now can this help maybe? Oh, this is low, right? Because if this is high, all 6, 7, 8, 9 are looking at this. So that's low. Low is our what? Pink. So that's 1, 2, 3, 4. Oh, 1 is already here. So that's 2, 3, 4. Right? That's high. And that must be 8, right? Because if this is high, again 6, 7, 9 all are looking at it. So that's 8. That's not 8. And that's low, which is again 1, 2, 3, 4. Cannot be 4 because 4 is not that much away from here. 8. And this is also cannot be 4 because it's not that away from 8. So I think we have done with 8 also because 8 is looking at this. So that's 6, that's 8. And now we know that 6 is here or here. Oh, 6 is here. Okay. Right. Look at this box. Where is 6 go? Look at this box. Where does 6 go? It's not here. It's not here. It's only here. That means 6 is not here. This is 6. And this 6 means this is 3, 4, 5, 6. And that means these all are 3, 4, 5. That's 1, 2, 1, 2. Anything else? Oh, that's it. 1, 2, 1, 2, 3, 4, 5, 1, 2, 2, 3. And that's 2, 3, 4, 5. But 3 is here. That means that's 2, 4, 5. Okay. Now can we do with 6? Right. In this box, where is 6? In this box, where is 6? 6 is this, right? In this box. That's the only possibility for 6, isn't it? 6 is not here, 6 is not here, 6 is not here. That's the only possibility for 6. And that means this is 1, 2, 1, 2, isn't it? So 3 is not here. Oh, sorry, my bad. 3 is not here. That's 1, 2, 1, 2. Oh, but we know that 1 is here. That means that's 2, that's 1, that's 2, that's 1. But more important here, because now this cannot be 1, 2, 5. This must be 1, 3, 4. The only possibility for 5 is here. The only remaining number 1, 3, 4. 3 is looking at this. That's not 3. 1 is looking at this. That's not 1. Nobody is looking at this. Okay. But we can remove now pencil marks. Okay. 1, 4, 3, 4, 1, 3, 4. And now we are done with all the clues, right? Except this one. come eventually. I think let's do this thing. This must be now 1 2 5, right? Mm, not resolving. 6 is here, we have said, right? 2 3, where is 2? 1 6 1 1 is not here, 1 is somewhere here. Oh, 1 is here, okay. 1 is not here, 1 is not here, 1 is either here or here, okay. Come on. What is this now? 1, we know it's 2 3 4 5, right? And this is not 2, that's not 5. 6. Oh, 6, looking at this, that's 1. That's 6. That's 6 6. Use 6 here. That's X wing of 6. But that one should help somewhere. Yeah, that help one should help. Put 1 here, isn't it? And that means that's not 1. 2 3 2 3 pair we got here. And that means this must be 1, right? This is not 1, yeah, right. That means this is 1, and now 1 is one of this thing, 1 is on one of the arrows. Okay, that's all about 1, we can say, right? 1 1, yeah. Some X wing of 1. What are these? These are 2 4 5, isn't it? That's not 5. 1 4 2 4 5 2 4 5 2 3 2 4 2 4 5 4. The only 3 here. No, 2 3 2 4. Okay. No. There are 2 3s here. Okay, nothing here. These arrows, right? Now these arrows are only remaining 8 2 3 2 3 9 2 3 4. Okay, 4 5 2 3 2 3 4. This is 2 3 4 5. Let's just park it there. What is this now? This cannot be 2. Can this be 3? Cannot be 3, right? Because that means 1 will be here and 2 will be here. If this is 4, 1 will be here, 3 will be here, that's fine. That could be 4 or 5, or could be 7. 7 is possible, right? Yeah, 7 is possible, isn't it? 7 7. Oh, this must be 7, right? By Sudoku, if you see 7 7, this is 7. 7 means this is not 1 6. Can this be 2 5? Yeah, it could be 2 5, right? This is not 1 6. That means this is 1. We know that this is not 1, because this cannot be 1 6. 6 is already present here. This could be 2 5 with 2 here and 5 here, or 3 4. Or 3 4. Okay. And now this one. So we have done with 1, right? Oh, this is 4 now. That's 3. That's 1. Okay. So that's not 3. 2 3 4. This must be 2 3 4 by Sudoku. 4 5 2 3 4 2 3 4. 4. 4. Oh, these are not 4. That's 2 5 2 5 pair. That means what is this now? 1 2 3 4 5 6. This is 7. Is it? Right, 7. The only remaining 7, that's here. What is this now? 2 3 4 5. Isn't it? 2 3 4 5. Now what could be this? Oh, this cannot be 3, right? Because 2 3 here. So what could this be now? It cannot be 1. It cannot be 2 3. Can it be 4? Yes, it could be 4. Can it be 5? Yes, it could be 5. Can it be 6? Yeah, it could be 6, but it cannot be 7, 8, 9. That's it. So it could be 4, 5, 6, and that means this could be 3, 4, 5, isn't it? Oh, it cannot be 3 because 3 is looking at here. So that's not 3. 4 5 4 5 pair we got. There is no 4 here. That's 2 3 2 3. 4 5, right? 4 5. This cannot be 4, isn't it? That's 5 or 6. 2 3. What is this now? Oh, this could be both, right? 2 or 3 or 4 or 2 or 5. Okay. Okay. 5 6. Anything else helping here? What are these two? 1 2 3 2 3 4 5. Okay. None of this is 5. 2 3 4 2 3 4 2 3 4. So this 4 5 is not resolved. Okay. Oh, 2 5 2 5. That's 4. That's not 4. Is that 4 helping somewhere? No, unfortunately. 2 3 2 5 3 5. 4 is somewhere here, isn't it? Mm, not much help. 4. What about 3? 1. 1 we have done with 2. Or 2 3 2 3 we already know that. That's not 2. 6. 4 5 4 5. That could be 5 6 2 3 4 5. Oh, 2 3 2 3, right? That's 4. If 2 3 2 3, that this will be 4. Oh, that clears this. That will be 5. That will be 4. That 5 must move 4 and 5 here. 2 3 2 3. We still get 2 3 2 3. That's not 4. That's not 4. Where is 4 here? Only 4 is here. That's not 4. Okay, that's even not 2 because of 2 here. So we got 3 5 3 5. 2 5 2 3. This will be 2 3 5. Oh, this is still not resolved. 2 3 3 5 6. What are these? 1 2 3 4 5 6. And that's not 6. 5. We haven't looked at 5, right? Oh, 5 is here or here in this box. 5 is here or here. Okay, yeah. That should resolve it. That means that's 6. That's 4. Because 5 is one of these. That's 4. That's 5. But 6 means that's 5. That's 4. That 4 gives this 3. Sorry, this 3. That 3 gives this 2. That's not 2. Uh, that's 2. That's 3. That 3 gives this 5. This 2. Uh, this 2 removes 2 from here. That's 3 4 3 4. That gives this 2. This 5. This 3. This 3. And these 2 digits are now. So these 3 gives as these 2. These 2 digits are 1 2 3 4 5 6. That 5 gives this as 6. This as 5. And this 2 gives this as 3. This as 2. That 2 gives this as 5. This as 2. That 5 gives this as 4. This as 3. Both these 3's are gone. This 5 gives this as 4. This as 5. And this 4 gives this as 3. And this as 4. And I think we have done with the puzzle. Okay. Okay, I think this was a. Yeah. Yeah, that was good. I think. I mean, I like the idea that. First of all, this thing, right? There was something going on here, which gives us, which will limit this, and then this digit is same as this one. I mean, the group is same as this one, and then this one. I mean, everything was related, right? This was related to this, then this was related to this. Then again, somewhere here we have used this because this cannot be 9. We place 9 here. I think this was a great puzzle. This is, I mean, everything was connected. Suddenly we get 1 6 here, which helps, I think, in later part to distinguish between 6 and 1, but of course not immediately. But then again, suddenly somewhere here we got lower digit 4. and then this must be 9, something like that. We suddenly got 8 here, because this 9 should be 8. So everything must be nicely connected, and I think the flow was really nice. And even this thing, right? Because this is 7, this cannot be 5. I think that logic was also very great. I mean, that's the purpose of this odd number. If this the odd concept would not have been here, then that would not have been possible. That deduction would not have been possible. I think this is a very good puzzle. I mean, everything just flows into place, right? I mean, everything was dependent on everything other. Uh, yeah, I think James Sinclair. This is very good puzzle. I mean, I really like it, and yeah, I think it deserves more than 90 to 95%. I think it deserves more than 95% of rating. I think this is very good. So yeah, I hope you guys have liked the video. So if you like the video, press the like button or press the subscribe button or comment anything if you feel that something could have been done better or anything like that. So yeah, but I think this is a great puzzle, and please try to solve this and let me know in the comments. Okay. So yeah, we'll end here, and thank you very much, guys.